You wake up one morning, go out to your home office and pick up your IP phone. When you turn it on, you don't receive a dial tone. And you think to yourself, what could be wrong? I know I go across the internet using a virtual private network to connect to the main office. So you pull out your packet sniffer and begin looking at the packets that are coming in and out of your network. In the end, you discover that you cannot connect to the call manager back at the main office. But then you wake up, because the reality is you don't know all of this stuff yet. And these are the things that you'll be learning about as we go through this course together to help you prepare for your CCNA certification and to help you get a fundamental knowledge base of networking concepts, technologies, and skill sets. My name is Tom Carpenter, and I've been working in the networking industry for, over 15 years now. And in all of that time, I've learned an awful lot about networking technologies. And one of the things that I've noticed over the years is that Cisco technologies have become more and more important. So in this course, we'll be looking at networking fundamentals from the perspective of Cisco devices. This ICND1 course is focused on providing an overview of the fundamental networking techniques, terminology, and technology for those learners that do not currently have a very strong technical background. The course is focused on providing you the information that you need to proceed into the networking industry, and also to help prepare you for the next step, which is the Cisco CCNA. We'll cover several concepts to make sure that we can accomplish these goals. And the first step is building a simple network where we will focus on exploring the general functions of networking. We want to be very basic here, understanding what makes a network actually function and what some of its main components are. We also want you to understand how to use a PC on the network. What parts, what software components and hardware components of a personal computer are actually used on the network. In fact, we'll interrelate with different networking technologies. We also want to understand the Open Systems Interconnect, or OSI model, which is a general framework that's been in use for almost 30 years now. This model provides us with a foundation for standards-based troubleshooting, learning, and implementation of different technologies. We'll understand what the OSI model is all about by the time we're done. We'll also see how to build a simple Ethernet network where we will first begin by defining a local area network environment. In addition, we want to understand how an Ethernet network works in a LAN environment. We'll become familiar with the different components of Ethernet, such as the history and the evolution, as well as the cable types and the connector types and so on. We'll also see different ways of connecting to an Ethernet LAN using a switch, a PC, and/or a router. In addition to this, we want to be able to expand the network, choosing the right network topology, whether that's a bus, a star, a mesh. In addition, we want to be able to expand the network using the right networking topology, whether that's a bus, a star, a mesh, or a partial mesh. We want to make sure that we understand how the appropriate topology relates to the underlying technology as well. Also, we want to understand the challenges of shared local area networks. What can be some mitigating factors when deploying a shared network, for example? Some factors to look out for from a performance standpoint or a cost standpoint. And also, how can we solve these challenges by using switched LAN technology? This means understanding how to maximize the benefits of Ethernet switching. In addition to expanding the network, we want to learn how to connect different networks together. How does TCP/IP work? The Transmission Control Protocol Internet Protocol, or TCP over IP, is one of the many foundations of networking today. In fact, the IP protocol is what makes the Internet function. We have to understand how this protocol works, how the IP protocol itself will process packets, and then how delivery is going to be made. We also want to understand how the IP protocol works so that we can actually implement an IP addressing scheme, including a subnet mask. And then we'll be able to explore the functions of routing. It's very important when connecting networks that we understand the implications of different numbering systems. It's also important to understand how to interrelate binary and hexadecimal as well as decimal numbering systems so that it makes more sense to us when we actually begin connecting these various networks together. The reason for understanding binary and hexadecimal number systems is very simple. We need to know how to construct network addresses based on an understanding of that binary math. We also want to ensure the reliability of data delivery. We want to understand how both the UDP, the user datagram protocol connections, and TCP connection-oriented models will work in the TCP/IP protocol suite. We'll establish a TCP connection and see how to troubleshoot one. We want to see how a TCP connection actually functions and understand how to troubleshoot a TCP connection for any applications that must use that transmission control protocol. We need to connect to remote networks from time to time as well, so it's very important that we understand wide area networking technologies. In addition, we really need to focus on dedicated connections so that we can understand how the IP phone can be connected over a virtual private network back to the office by utilizing the internet as our connection. It is extremely important for us to understand all of these topics and technologies to be able to proceed to the next level. We also have to focus on circuit switching and packet switching and understand the major differences between the two when dealing with wide area network solutions. The idea is to know the difference between a dial-up connection and using something like frame relay or using a T1, which you might have heard of in the past. We also must focus on getting ourselves prepared for what is necessary for the next step of Cisco's level of training and certification. For this purpose, it's important to know how to operate and configure Cisco iOS devices. We need to understand the Inter-Network Operating System software, or the iOS software, and how to operate this software as it pertains to the various physical devices. This means starting a switch, understanding how that switch startup is going to function, as well as starting and configuring a router. Before you take the CCNA exams, you should know how to interconnect the Cisco network devices as one of the prerequisites. It's also important that you be able to understand how the Inter-Network Operating System works, how you can apply its technologies, and these two primary devices, the switch and the router. We're going to use a series of pictures and labs and so forth to make sure that you have a good understanding of all of these different technologies. And these are some of the icons and symbols that we're going to be using throughout the course. Number one, we have the workgroup switch. This is a universal icon used for a switch, typically functioning at layer 2 of the OSI model. You'll see this in different Cisco diagrams. Number 2, the universal symbol for a Cisco router is also very important. And number 3, anytime we have an element of layer 3 of the OSI model, which we have yet to learn about, we're going to see an icon like the one represented here. This is a dedicated router typically used to terminate connections between a local area network, such as an Ethernet line, and a wide area network, such as a serial line. With a multi-layer switch, we typically have a device that can handle both functions. It has a lot of ports like a switch or a hub and can provide us with the same types of technologies that a router can, such as packet manipulation. So these 3 icons are paramount, and we will see these in many different places throughout our course. In addition, the hub or concentrator is used to define a non-intelligent layer 1 device, but doesn't do anything special to the packet at all. It simply allows computers to connect via Ethernet. Of course, the PC computer and the server will be used to represent a PC and a server, respectively. And when we utilize the asynchronous transfer mode, or ATM, as either a LAN or a WAN technology, we might see one of these switches used here and there. We will typically also see a network cloud anytime we're dealing with an environment where we have connectivity from one end to the other. This is typically where the network cloud icon comes from. We also have a difference between the Ethernet line, which is typically a local area network connection, and the serial line. A serial connection can be considered the same as a wide area networking. So we will typically see a little lightning bolt anytime we're dealing with a WAN connection. We typically see a straight line anytime we're dealing with a local area network connection. Now, it's very important that you familiarize yourself with these icons. You're going to see them again and again. They'll be used in Cisco documentation, at their website, and in other books as well. And the good news is they're not likely to change anytime soon, and we've been using them for a lot of years. These icons will help you to understand the technologies as we go along. And you want to make sure that you have the right terminology and the right technologies in place for your network so that you'll be an excellent Cisco engineer.